Okay, previously we looked at this equation. Characteristic equation clearly has solution R equals plus or minus the square root of negative rho omega squared over big T, which is this. Okay, this is what I should have written as the coefficient of T here. I just didn't look at what I wrote. I went on and interpreted it in terms of wave velocity and so forth, but I had the wrong expression here. So this is wrong. Should be the cosine of square root of rho over big T omega squared T plus phi. And from physics, and this goes back to the wave equation, and it's still not, yes, keep putting the right omega squared. Okay, it wasn't right, there it is, okay, this is right. C is your velocity of wave propagation, because, well, that's your square root of rho over T, okay. It's like the speed of propagation in a string of mass per unit length, rho, and tension T is the square root of T over your mass per unit length, which is very familiar when you're up on the propagation of waves in a uniform string. T is a tension, rho is like your mass density. Makes a lot of sense. It's this, and it's not T. You know, part of this is allergy season, and part of it's just, I don't know what it is. The variable here is x, because you're looking at the configuration of the wave in space. Okay, so I finally have it right. And now I can write what I wanted to. This would be the cosine of kx plus phi. K equals omega over c is the wave number. In your general context, is like y equals a cosine of kx minus omega t. And you could have a phase angle in there. But omega is your angular frequency that determines the frequency of oscillation. And your k is your wave number, which is like how many waves squeeze into a unit distance. How many complete cycles squeeze into a unit distance. So, I apologize for the errors. I'm making way too many of them. And when I looked back at the video and saw that, I almost gave up. Not really, but didn't make me real happy. So anyhow, there it is.